Today we're talking about the converse of the Pythagorean theorem. Now, if you remember, back in the first trimester that you did this, we talked about the original statements that you could have and how you can have the converse of the statement. The original statement was if and then your converse is where you switch the if and the then. So yesterday we talked about if you have a right triangle, then a squared plus b squared equals c squared. So today is the converse, so we're flipping the if and the then part. So if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. Okay, so in this case we don't know which is the hypotenuse because we're not sure if it's a right triangle. So you're taking the longest side of the triangle, and that one would be what your hypotenuse would be. Okay, so in this first one, we need to decide which is the longest side. So by looks, this looks the longest, but we can double check. So if you want to on your calculator, you can do 4 root 95, and you get 38.98. So this is going to be the longest side. So this is going to be the one that's like our hypotenuse. So I'm going to set 4 root 95, and I'm going to see if that's going to be equal to 15 squared plus 36 squared. So in my calculator, I do 15 squared, which is 225. And then I do 36 squared, which is 1296. And then when you do 4, I forgot to put my squared here, go back and fix that. So when you do 4 root 95 squared, it squares the 4 and it squares root 95. So I end up with 16 times 95. Okay, so 16 times 95 gives you 1520 equals 225 plus 1296. So 1521. Okay, so notice these are close, and we're asking, are these the same? This is our question, and it's not the same. So this is not a right triangle. Okay, so that is the same picture. So we're going to skip this one because it's the same picture. That was my fault. Sorry. So we're going to look at this one. So between 97, 72, and 65, you're asking which one is the longest side. Well, 97 is the longest side. So I'm going to do 97 squared, and we're going to see is that equal to the other two sides squared. So 72 squared plus 65 squared. Okay, so if I use my calculator, 97 squared is 9409. Now on your calculator, if you have a TI-83, your squared button is diagonally up and left of the 7 button. Okay. The other option is you could do 97, and then this button right here above the divide sign is called a caret, and you could do caret 2. Notice it gives you 9409 either way. So 9409 equals, we're wondering if it equals, 72 squared, which is 5184, plus 65 squared, which is 4225. Okay, so now I'm going to add these two together and see if it's the same as 9409. So if I do 4,225 plus 5184, that gives me 9409. So these are equal. So since these two are equal, then this is a right triangle. Okay. Our last one, I guess it's not our last one. The next one I'm going to look at, root 26, I want to know what that is as a decimal. So it's 5.099. So this one is our longest side. So I'm going to set root 26 squared equal to this side squared plus that side squared. So 1 squared plus 5 squared. Root 26 squared, the square root and the squared undo each other. 1 squared is 1 plus 5 squared is 25, so I get 26 equals 26. So that is correct. So this is also a right triangle. Okay, so we're going to try our last one, maybe it's not our last one. Well, the last of this example. Okay, so our longest side we want to figure out. So I want to figure out what 3 root 3 is. So in my calculator, I do 3 root 3, and this is 5.196. So between 5.2 and 5.196, this is the longest side. So I'm going to set 3 root 3 quantity squared equal to, because that would be our hypotenuse if it ends up being a right triangle, equal to 5 squared plus 2 squared. So when I square this, remember I square both the 3 that's outside of the root and I square the root 3. Oops, square the root 3. So 5 squared is 25, 2 squared is 4. So now I have 3 squared is 9, root 3 squared, remember the squared and the root undo each other, so I just get 3. So I have 25 plus 4 is 29, and 9 times 3 is 27. So these are not equal, so this is not a right triangle. Okay. Now we have something called Pythagorean triples. Okay. Our Pythagorean triples are sets of 3 that work for any Pythagorean theorem. This is actually out of order from yesterday. I put it in the wrong spot, but that's okay. We will still mention it here. Okay. So these ones would be good to memorize. They come up a lot. So if you have 3 and 4, the next one's 5. If I have 5, 12, and 13, those make a right triangle, and they're a Pythagorean triple. 8, 5, 17, 7, 24, and 25. Okay. Now any of these that are multiples of these also work as well. So if I were to take 2 and multiply each one of these sides by 2, so I get 6, 8, and 10, that would also be a Pythagorean triple. So these are the ones that show up the most frequently. They would be good to have memorized so that you can do things quickly, so you don't always have to find the Pythagorean theorem, the missing side with the Pythagorean theorem. So if I had 3, 4, then I would know the other side was 5, as long as it was the hypotenuse that was missing. Okay, so our theorem 9.6 says, if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other 2 sides, then the triangle is acute. So we have if c squared is less than a squared plus b squared, then ABC is acute. Okay, so this is nice because now with the information that we were just doing, we can tell if it's an acute triangle or an obtuse triangle. Okay, and then similarly, 9.7 says, if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other 2 sides, then the triangle is obtuse. So if c squared is greater than a squared plus b squared, then it's an obtuse triangle. Okay, so now what we can do is decide if it's a right triangle, if it's obtuse or acute, all using the same process. So in these problems that we have, instead of having the triangle written, you can just use the sides. Okay, I could give you either. So in this example, the 86 is the longest. Okay, so I'm going to set 86 squared, and I'm wondering, is it going to be greater than, less than, or equal to 77 squared plus 38 squared? Okay, so if I do 86 squared, I get 7396. And we're still wondering if it's going to be greater than, less than, or equal to. 77 squared is 5929, and 38 squared is 1444. So if I add 5929 to 1444, then I get 7373. Okay, so the question is 7396 bigger, less than, or equal to 7373? So it's greater than, so notice up here, if our c squared is greater than, then this means this is going to be an obtuse triangle. So this is obtuse. Okay. On the next one, our 37.5 is the longest one. So I'm going to do 37.5 squared, and I'm wondering, is it going to be greater than, less than, or equal to 10.5 squared plus 36.5 squared. Okay. So 37.5 squared is 1406.25. And I'm wondering, is that going to be the same as, or less than, or equal to 10.5 squared is 110.25, and 36.5 squared is 1332.25. So if I add these two together, I get 1442.5. So is 1406 less than, greater than, or equal to 1442.5? It's going to be less than, so this is going to be acute. Okay? Try this one on your own, see what you come up with. Okay, welcome back. This one's the longest, so I do 11 squared equals 2 squared plus 10 squared. So I have 121 equals 4 plus 100. So 121, oh, we're checking to see, sorry. Is it equal to, is it less than? So 104, so 121 is greater than, so you should have got obtuse. Okay? If you didn't get obtuse, make sure you go back and figure out where you messed it up. Okay, let's try the next one. 7, 24, and 25. Notice that this is one of our Pythagorean triples up here. So we could say, well, it's a Pythagorean triple, so it's going to work if you have that memorized. We're going to show show all the steps and show that this is indeed a Pythagorean triple, and therefore a right triangle. So this is the longest, so that's going to be our 25 squared, and we're going to see, is that equal to 7 squared plus 24 squared? So 25 squared is 625. 7 squared is 49, and 24 squared is 576. So if I add 49 to 576, I get 625. So in this case, 625 equals 625. So then this is a right triangle. Okay. I'm going to let you try these two by yourself and have them filled out on the notes. Let's move on to the next part. Okay. So we have some theorems that talk about the relationship between the sides and the angles. Okay, so the theorem says if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So that's a mouthful, but it's really simple to put into words. So what it basically says is across from the longest side is the biggest angle. Okay? If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Okay? So what we have here is that you now can order your angles. Sorry about the pause in the middle there. You can now order your angles based on the sides that you're given, and you can order the sides based on the angles that you're given. So if the smallest angle is across from the shortest side, the middle angle is across from the middle, and the biggest is across from the longest. Okay? So now we can figure out which is, and we can order them. Okay? This is a little bit light to see, but this is 110 and this is 20 degrees. Okay? So 110 is the biggest, so this side is going to be the longest. 50 is the middle, so this is going to, across from the 50 is going to be the middle side. 20 is the smallest, so this is going to be the shortest. So if I want to list the sides from smallest to greatest, I'm going to list EF is the smallest. Remember, you put a line above to signify it's a line segment. Then the middle is DE, or ED, either way. And then the longest is DF. Okay? Try this one on your own, see if you get it right. Okay, welcome back. Let's see how you did. Okay, this is the smallest, this is the middle, and this is the longest. So this should be your longest side, this is the middle side, and this is the shortest side. So then you should write it as IH, then IJ, G, sorry, and then GH. Okay. Now we can go backwards. So I now have the angles, or sorry, the sides, and I can list the angles from smallest to greatest. Okay. So this is the longest side. Nope, that's not the longest side. 8's the longest, sorry. 5 is the shortest, and 7 is the middle. Okay. So across from the shortest side is the smallest angle. Across from the middle is the middle, and across from the longest is the biggest. Okay? So if I want to label them, it goes angle L from smallest to greatest, angle L, then angle K, then angle J. Okay? Try this one by yourself, see if you get it right. Okay, let's see how you did. This is the longest, this is the middle, this is the shortest. So this angle is the biggest, this angle is the middle, and this one is the smallest. So you should have, if you're listing from smallest to greatest, you should have angle O, then angle M, then angle N. Okay, go back and make sure that you did that correctly. If not, fix it. Okay, our last theorem for the day is the triangle inequality theorem. Okay, this says that the sums of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so if I add any two together, it's going to be longer than the other side that you didn't add. Okay, so if I take this side and this side, add those together, it's going to be longer than this side. If I take this side, and this side, it's going to be longer than this side, and if I take this side and this side, it's going to be longer than that side. So what we can do now is, given any three numbers, I can determine if the triangle is going to be, if the numbers allow a triangle to be made, or if one side is going to be too short or one is too long or something like that. Okay? So what I do is I set up two of the sides and see if it's greater than the third side. So if I do 3 plus 2, that has to be greater than 5. Okay? This is not greater than 5. It's equal to 5, but it has to be greater than. So this cannot make a triangle. Okay? So I don't have to check the other two because the first one didn't work. On the second one, if I check 4 plus 2, that has to be greater than 5. Well, 6 is greater than 5, so I'm okay there. So I add another 2 set, so 2 and 5. That has to be greater than 4. So 7 is greater than 4, so I'm okay there. So my last one is 4 plus 5, and that has to be greater than 2, and 9 is greater than 2, so I'm okay, so this creates a triangle. Yes, it's a triangle. Okay, so try this last one on your own. Okay, let's see how you did. 2 plus 9 has to be greater than 7. 11 is greater than 7, so I'm okay. Then I have 9 plus 7 has to be greater than 2. That's 16 is greater than 2, so I'm okay there. And then our last one is 2 plus 7 has to be greater than 9. 9 is not greater than 9, so there's no triangle. Okay. The last kind of thing that we could have is where I give you two sides and you decide the range of the third side. Okay, so if one side is 10 and one side is 14, I'm going to do 10 plus 14 has to be greater than my third side that I'm going to call x. Okay, and then I can do 10 plus x has to be greater than 14, and then 14 plus x has to be greater than 10. Okay, so now if I simplify these, I have, if I subtract the 10 here, this gives me x has to be greater than 4. This gives me, if I subtract the 14, x has to be greater than negative 4. And then on this last one at the top, 24 has to be greater than x. So you can also rewrite this as x has to be less than 24. Okay? So my x has to be greater than 4, but it has to be less than 24. Notice between these two that this is the one that you want. It has to be greater than 4 but less than 24. So my number for the third side could be in between 4 and 24. Okay? And that's what we have. So make sure that you go into your notebook and you write the answers to the questions and that you come up with one question for this video.